Today is the review day. You guys should be building your half sheets, and then after working on your review, the test format. There's essentially 3 types of questions. So, given a rational function, I'm going to ask you to find the vertical asymptotes, the horizontal or other asymptote, and the end behaviors. How am I going to ask you to write the end behaviors? Using limit notation. So if you're soft on that notation, make sure you get that into your half sheet. You'll be asked to solve a rational equation and be able to solve an inequality using a sign diagram. Okay? So I think it's 332 is the number of questions of each type. How do we find vertical asymptotes?
Set the denominator to equal.
Close.
Not 0.
Alex.
Set the
reduced denominator equal to 0. Because if you don't reduce, what might you not catch? You might mistake a whole for an asymptote, right? Yes.
When do you do the setting it equal to non-zero?
The domain. Krista. They ran out yesterday. Would you like to go to the bathroom? Go ahead. How do we determine if we have a horizontal or other asymptote?
Compare the degrees of the numerator.
Great, we compared the degree of the numerator with the degree of the denominator. What are the 3 possibilities? Numerator. The numerator is greater than, what's that mean? Okay, and how do we find the OA? We use polynomial division. Could be synthetic if the denominator is okay to do that. And then what part of the division problem gives us our equation? The quotient, right? Not the remainder part. Everybody's okay? What if the degrees are equal? So then we get what type of asymptote if they're equal? Horizontal, and the equation is y equals?
Leading coefficient of the numerator over.
Good, leading coefficient of the numerator over leading coefficient of the denominator. What happens if numerator less than denominator? Just y equals 0. Horizontal asymptote, every single one of them, y equals 0. Everybody's okay? And then the end behaviors we've talked about. How many end behaviors are you going to get?
At least
2 times the number of vertical asymptotes plus 2, right? 2 for each VA and then the 2 at the end. Everybody's okay? When we write the end behaviors for the vertical asymptotes, what do you need to have? X approaches a number. What else are you going to need?
the superscript.
The superscript, the plus or minus, depending on whether you're talking about the left side or the right side of the number. Everybody remember that? Okay. To solve a rational equation, what's the process we use to do that? Clearing fractions. And how do we clear fractions? We multiply both sides of the equation by the least common multiple of the denominators. Everybody's okay? So you absolutely need to be able to find an LCM of polynomials, or else that problem becomes real messy if you use just a common multiple and not the least common multiple. To solve an inequality, we make a sign diagram. How do we find the numbers that we need to put on the sign diagram? We set the function equal to 0 and also undefined. Everybody's okay? Those numbers go on the number line. Then what do we do?
You see if when you plug the numbers in that range.
We pick a test value from each interval that the numbers divide the number line into. And then
you see if it results in a positive or negative.
Perfect. Yes, and then how do we decide whether the numbers on the number line are open or closed?
Is it greater than or equal to, is it equal to is equal to 0?
So the numbers that come from the equation set equal to 0, those will depend on the type of inequality, right? If it's a strict inequality, they're open. If it's a closed interval, or inequality, they're closed. The numbers that come from the undefined, always open. Okay? That's essentially the rundown on the processes. Now there's like detail in between, but like I would think that information that we just kind of walked through, if you don't have that committed to memory now, is stuff I would put on my note card, or even if you like think you got it now, probably still a decent idea to put on your note card. Past that, seems like examples would be a good thing to put on there. Particularly if you're like, ooh, the details for this particular problem kind of get me. Like if you're bad with the polynomial division or something and you need I need an example of that, that feels like a good thing to put on your note card if you're like, yeah, that part, I always kind of get hung up on that or whatever. But we just ran through basically the procedures on how to do each one of these. Several of us seemed like we felt pretty comfortable there. If you didn't feel good about the things that we were saying and you're like, yo, that's a bunch of Greek to me, really spend some time here and go through your card in good detail. When I see you guys again on Monday, we're just going to kind of start chapter 15, because I'm not going to ask the A block or A period kids to take the test in a 40-minute class. So we're going to just kind of start the next chapter a little bit, and you guys will take your test on Wednesday, your next class day.
So the note card due by the end of the day today? Or?
Yes,
Is our next class Monday or Tuesday?
Monday.
Because last time you let us have an extra day to have things to our note card after we finish.
Well, you can, if you want to come back on Monday and make some additions to it, I'd be happy to let you do that.
Yeah.
But I'd like to collect them today to make sure that over the long 3-day weekend, you don't forget to do it, because the odds of that happening for some of us are real high. If I say, oh, you can just turn it on Monday, you're going to forget to do it at all. I'd rather have you do it today, take the stuff, and if you go home over the weekend and you're like, oh, I want to add some stuff to it, you come with some notes of your own and I'm going to add this to it. Happy to let you do that on Monday. Good compromise?
Yeah.
Okay, I like that too.
May I borrow a piece of paper?
There's blank computer paper on top of the podium and scissors in the cup. You're welcome to it.